To determine the appropriate size of grounding electrode conductors for service entrance, we refer to the National Electrical Code, specifically Section 250.122. This section outlines the requirements for sizing these conductors based on the size of the ungrounded service entrance conductors. In this scenario, there are 8 sets of 750 kc mil aluminum conductors in 8 4-inch polyvinyl chloride conduits, feeding a 2500 amp main. The system is a 120/208 volt 3-phase 4-wire configuration with a full-size neutral. Additionally, there is a 4/0 ground grid at the transformer and a 3/0 ground to water at the main distribution panel. The question is whether 600 kc mil aluminum conductors are required in each of the 8 service entrance conduits to comply with NEC 250.122. According to NEC 250.122, the minimum size of a service entrance conductor should be based on the calculated load multiplied by the demand factor for the specific use and occupancy. For a 3-phase, 4-wire, 120/208 volt system with a full-size neutral, the demand factor for residential and commercial occupancies is 100%. Therefore, the minimum size of the service entrance conductor is determined by dividing the calculated load by the demand factor. Assuming a calculated load of 2500 amps, the minimum conductor size is 2500 amps divided by 100%, which equals 2500 amps. NEC Table 310.16 provides ampacity ratings for conductors under various conditions. For a 3-phase, 4-wire, 120/208 volt system, the maximum ampacity of a 750 kc mil aluminum conductor in a 4-inch polyvinyl chloride conduit is 1830 amps. Since the required conductor size of 2500 amps is greater than 1830 amps, a larger conductor is needed. The next largest size of aluminum conductor listed in NEC Table 310.16 is 600 kc mil, which has an ampacity of 2300 amps in a 4-inch polyvinyl chloride conduit. However, this ampacity is not relevant to the grounding electrode conductor size because the grounding electrode conductor is sized based on the size of the service entrance conductors, not the load. NEC 250.66 dictates the sizing of the grounding electrode conductor. In general, the grounding electrode conductor must be sized no smaller than specified in Table 250.66, based on the size of the service entrance conductors. The service entrance conductors are 8 sets of 750 kc mil aluminum. According to Table 250.66, for aluminum service entrance conductors, a grounding electrode conductor is selected based on the equivalent copper size for the aluminum conductors. 8 750 kc mil aluminum conductors in parallel are equivalent to a very large copper conductor. Consequently, the grounding electrode conductor will need to be very large as well. Looking at Table 250.66, if the service entrance conductors are larger than 1100 kc mil aluminum, the grounding electrode conductor must be at least 3/0 copper. This applies to a connection to a ground rod, pipe, or plate electrode. If the grounding electrode conductor is connected to a concrete encased electrode, the grounding electrode conductor needs to be at least 4 American wire gauge copper. If the grounding electrode conductor is connected to a ground ring, the grounding electrode conductor needs to be at least the same size as the ground ring, but not smaller than 2 American wire gauge copper. The initial statement is that the system has a 4/0 ground grid at the transformer, 3/0 ground to water at the main distribution panel, and the question of whether 600 kc mil aluminum conductors are needed in each of the 8 service entrance conduits to satisfy NEC 250.122. Note that 250.122 pertains to equipment grounding conductors, not grounding electrode conductors. Equipment grounding conductors are sized to provide a low impedance path for fault current back to the source. Grounding electrode conductors connect the service equipment to the grounding electrode, such as a ground rod, water pipe, or concrete encased electrode. Given this context, and focusing on the grounding electrode conductor requirements, and based on the previous calculation, the 600 kc mil aluminum in each conduit does not pertain to the requirements of NEC 250.122, but more so with 250.66. However, the 600 kc mil aluminum may be used as the grounding electrode conductor provided it meets the requirements of NEC 250.66 based on the electrode type. For example, the 600 kc mil aluminum could be used to connect to the ground grid or water pipe if it is not smaller than the required size specified in 250.66. To correctly answer whether the statement is correct, it is important to understand the specific purpose and requirements of each conductor as defined by the NEC. In this case, the grounding electrode conductor is sized according to NEC 250.66 and Table 250.66 based on the size of the service entrance conductors and the type of grounding electrode used. The equipment grounding conductors within each conduit are sized according to NEC 250.122. Because this question is in regards to satisfying 250.122, it is important to note that it applies to equipment grounding conductors. The 600 kc mil aluminum conductors are required as equipment grounding conductors in each of the 8 service entrance conduits to satisfy 250.122. To further explain the requirements for equipment grounding conductors according to NEC 250.122, it is important to consider the purpose of these conductors. Equipment grounding conductors provide a low impedance path for fault current to return to the source, which helps to facilitate the operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. The size of the equipment grounding conductor is determined based on the size of the overcurrent protective device protecting the circuit. Specifically, NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device. In this scenario, with a 2500 amp main, the equipment grounding conductors need to be sized appropriately to handle the potential fault current. Given that the service entrance conductors are 8 sets of 750 kc mil aluminum, a substantial equipment grounding conductor is necessary. While 600 kc mil aluminum may seem large, it is likely required to meet the requirements of NEC 250.122 for a 2500 amp service. There may be other considerations. Firstly, the specific requirements for equipment grounding conductors can vary depending on the application and the type of equipment being served. Secondly, local codes or regulations may impose additional requirements beyond those specified in the NEC. Thirdly, it is important to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. To provide further clarification on the distinction between grounding electrode conductors and equipment grounding conductors, it's helpful to reiterate their distinct roles in an electrical system. A grounding electrode conductor connects the service equipment to a grounding electrode, such as a ground rod, water pipe, or concrete encased electrode. This connection establishes a reference to earth, providing a path for fault current to flow back to the source and helping to stabilize voltage during normal operation. An equipment grounding conductor, on the other hand, provides a low impedance path for fault current to return to the source from equipment enclosures and other non-current carrying metal parts. This path helps to ensure that overcurrent protective devices operate quickly in the event of a ground fault, minimizing the risk of electrical shock or fire. In summary, grounding electrode conductors establish a connection to earth, while equipment grounding conductors provide a fault current path back to the source. Both types of conductors are essential for ensuring the safety and reliability of an electrical system. In the context of the given scenario, the question focuses on whether 600 kc mil aluminum conductors are needed in each of the 8 service entrance conduits to satisfy NEC 250.122. Given that NEC 250.122 pertains to equipment grounding conductors, and considering the size of the service entrance conductors and the potential fault current, it's plausible that 600 kc mil aluminum conductors are indeed required to meet the code requirements. This is because NEC 250.122 dictates the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. With a 2500 amp main, a substantial equipment grounding conductor is necessary to handle the potential fault current effectively. Therefore, to definitively answer the question, it's essential to consult NEC Table 250.122 and verify that 600 kcmil aluminum conductors meet the minimum size requirements for a 2500 amp service. Additionally, it's advisable to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. One final important note: the purpose of an equipment grounding conductor is to provide a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices in the event of a ground fault. The size of the equipment grounding conductor is determined based on the rating of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. Equipment grounding conductors must be installed in the same raceway or cable as the circuit conductors they serve. This ensures that the impedance of the fault current path is minimized, allowing for rapid and reliable operation of overcurrent protective devices. Additionally, equipment grounding conductors must be connected to all non-current carrying metal parts of equipment and enclosures, ensuring that these parts are effectively grounded and that potential shock hazards are minimized. Considering the potential for high fault currents in a 2500 amp service, the use of 600 kcmil aluminum equipment grounding conductors may indeed be necessary to provide an adequate fault current path and ensure compliance with NEC requirements. In conclusion, the question relates to the sizing of equipment grounding conductors according to NEC 250.122 for a 120/208 volt 3-phase 4-wire service with 8 sets of 750 kcmil aluminum conductors and 8 4-inch polyvinyl chloride conduits, feeding a 2500 amp main. To determine whether 600 kcmil aluminum conductors are required in each of the 8 service entrance conduits, it's essential to consult NEC Table 250.122 and verify that they meet the minimum size requirements for a 2500 amp service. It is also important to consider the specific requirements for equipment grounding conductors, including the need to provide a low impedance path for fault current, install conductors in the same raceway or cable as the circuit conductors they serve, and connect conductors to all non-current carrying metal parts of equipment and enclosures. In summary, based on the information provided, it is possible that the 600 kcmil aluminum equipment grounding conductors are indeed required to meet the requirements of NEC 250.122, but verification with the applicable code table and consultation with a qualified professional are recommended to ensure compliance.